We're going to look at geometric vectors primarily. Now, one way, if you're taking physics, that we can add vectors is what we call the head-to-tail method. And that's very simple to know. If I have a vector, let's call it vector v, and I want to add that to, let's say, vector w. From pre-cal, or from physics, you learned if I wanted to take vector v plus vector w, I would add them together. I would start with vector v, and at the head of vector v, we put the tail of vector w going in the same direction. And this right here, this vector down here where they connect, is what's called our resultant vector. Very quick review. Now, because vectors are directional, we can say that vector v and negative v are going in opposite directions. And again, that's pretty easy to show as well. If this is vector v heading to the right, negative v, same length, just heads in the opposite direction. And we're going to use these to help us solve some geometric vectors. Most of these are fun until we get to the second part, in which case most of you will probably wind up crying. So that's okay. All right. So we're given a parallelogram here. And what they tell us is that BC is donated by vector x. Now, because it's directional, B is traveling in the direction of C. So if BC is x, what would C be? B. Very good. Negative x. Okay? So keep that in mind. And CD is y. P is the midpoint, so we know that these are midpoints. Okay, so we know these are the same length. There we go. Find each of the following in terms of x and y. So the first thing they want me to do is find AD. Well, AD, because it's directional, AD, it's a parallelogram, it's going in the same direction as BC. So AD is going to be the same as BC. But they don't want me to put it in terms of BC, they want me to use x and y. So that's just x. To get AB, now be careful, AB goes in the opposite direction of CD. Remember, CD is y. So AB is going in the opposite direction of CD. So AB, CD, they go in opposite directions. So it's the negative of it, I say. So we say that's negative y, and there's our answer. All right, let's get BA then. Well, BA, now that's traveling in the same exact direction as CD, so that's going to be y as well, going in this direction. So that's just y here. All right, how do we then get BD? All right, now the fun begins. Now we have to think about adding vectors, and this is kind of fun. This is where we got to kind of think a little bit. If I want to get BD, it's directional. I don't have anything tells me what BD is, so I have to think in terms of my vectors. BC travels this direction. I'm starting at B, heading towards C. CD starts at C, ends at D. Well, if I think about it, if I want to go from B to D, using what I know, I can go from B to C, from C to D. I can add those. So I can go from B to C, and then from C to D. B, D, B, D. Well, BC we know is X, CD we know is Y. And there's our answer. How then can we get CB? Well, CB, well, we already know what BC is. Remember, this is just the opposite of BC. So that just becomes negative x. All right, BP, yuck. Okay, BP's not that bad. Remember, BP is in the same direction as BD. We got BD earlier, but we're only going halfway. So this is going to be 1/2 of BD. And I can just write this as 1/2. This is x plus y. And there's our answer. Very easy. Now, how then would we get CA? Well, to get CA, be very careful. We're starting at C, we want to get to A, but I don't have the direction here, so I can think of adding them. I could go from C to D, because I know what CD is. I can go from D to to A, because I know what D to A is. DA is just the same as X, but be careful. We'll talk about that. It's opposite, though. So from here, I'm going to go from C to D plus DA. CA, CA. The ends should always match up right there, and the middle should kind of like cancel out if you think about it. CD, we know, is Y. Be careful. DA is the opposite of BC. It's the opposite because BC goes towards the right, and that's X. DA travels left, so it's going to be the opposite, so that's negative X. So we should get Y minus X for this one. PA, well, we already got CA, now we want to get PA. Well, CA is twice PA, so PA is just 1/2, again, CA. So we get 1/2 Y minus X. Very easy to do. All right, let's get PC. All right, well, PC still is 1/2 CA. It's still 1/2 CA, but the problem is now I'm traveling in the opposite direction. So I have to make this negative because we're traveling in the opposite direction of CA to get PC. Does that make sense? So what do we get here? We get negative 1/2. Again, this becomes Y minus X. And there's our answer. So if you need to, go back and try these again. These are kind of fun to do. We're going to take a look at these for a couple of days, okay? All right. Now the next ones are a little bit more challenging because here's what they tell us. They tell me this ratio. AP is 3, PB is 1. P to Q over C to Q to C is 1 to 4. All that's basically doing is giving us length. They're telling me the distance from A to P is 3, and the distance from P to B is 1. So the whole length is 4. Now, P to Q is 1, Q to C is 4. So the whole length there is 5. Now what they tell me is that PQ is defined to be X. I'm going to put that in red. This is defined to be X as well. And then they tell me that QB, whoa, there's no length QB. Guess what we got to do? QDs. We got to put it in there. From Q to B, it's Y. And now they want us to express all of these in terms of X and Y. Let's have some fun. All right. P to B. That's not bad to do. PB. Right. Now, to get P to B, I got to think. Directional. Okay, to get from P to B, what am I going to do? I'm not told it as X or Y. I know it's 1, but I don't want it in terms of 1. So I got to think directional. It's going to start at P. I know P to Q, and I know Q to B. So I'm going to add them. This is P to Q plus Q to B. Well, P to Q, they told me was X. That's what I like these little hats on, directional. And then Q to B, they tell me is Y. So this is just X plus Y hats. To get PC, be very careful. P to C, now be careful. It's traveling along the same direction. P to Q is 1X. Well, Q to C is just 4 times that. So we can say Q is, from Q to C, is 4X. And I can just add those together. So this is kind of a fun one right here. We can just say this is just P to Q plus Q to C. PC. Q's cancel. P to Q we know is just X. And we just said this is 4 times that. So we just get 5X. To get BC, tough one. Now, I don't know B to C directly. But I can do this. I know B to Q is Y. I know Q to C is 4X. So I'm thinking vector addition. Boom, if I take B to Q, I always think like giving directions. Okay, you're going to start at P, and you're going to head straight to Q. Once you get to Q, you're going to hang a right and go straight on to C. It's like a direction. P to Q, and then from Q to C. That's how I get to C. I can't take the direct route because I don't know what that is. So PQ is, be very careful, PQ, oh, BQ. That should be BQ. Awful. BQ. Sorry about that. BQ is the opposite. It's negative y. See, QB is y. But if I switch directions, now sometimes we can write it this way. That's negative QB, right, plus QC. So that helps me to go negative y plus, and we just said that's 4x. And there's our answer. All right, number 13. Let's take a look at 13. AP. I want to get AP. Oh, that's easy. Duh. P, Q to P, directional. We got that. P, B. Boy, I can't speak right. All right, so to get A to P, what we're going to do is we know it's on the same direction as BP. Well, BP we know is 1, right? And this is just 3 times that. Okay? So, to get this, to get AP, it's going to be 3 times PB. I'm going directional. Okay? Well, we got BP earlier. It's just the opposite direction. So I'll go 3 times the opposite of BP, which becomes negative 3 times, and what was BP? X plus Y. All right. We're going to take a look at the rest of these tomorrow as a class before the quiz, okay? So make sure if you want to try these, go ahead and do so, okay? We'll see you then. Rework some of these if you need to. Bye.